Hey guys, Cameron here with Defacto. Today I want to give a presentation that I was going to give as a lunch and learn, but I wanted to make a video out of it so that everybody could, see what I wanted to present in the presentation. So yeah. So this is entitled "More Unit Testing: Common Pitfalls and How to Avoid Them." This presentation I decided to give it because the last one that I gave, I had some people come up to me afterwards and ask me all sorts of questions that I kind of had to go away. I had to think about it. I had to come back, and there was a lot of discussion. So I decided, well, let's throw that all into a PowerPoint presentation and give it to everybody because if a couple people are having this question, maybe other people are stuck on that same question as well. So okay, so this presentation I'm going to be going over a couple things. First, I want to start with some phrases that I've heard, not from only from myself, but from other people as well. The first one being, my application is too simple to need tests. I'm trying to test Entity Framework and I'm stuck. My tests are a black hole. As well, I'm going to be going over testing when you're dealing with clients and QA, as well as Specflow and Cucumber, which are two tools, I guess, that you can use to help advance your testing capabilities. So to start off with, my application is too simple to need tests. Basically, I ran into this problem, and I've heard other people run into this problem. Basically, I sat down and I said, okay, I've written some program code, and I have stuff working, and now I want to write some tests for it. But, well, it only does this one thing, so, I can't really test that. This class, the only thing it ever does is write to the file system and deal with files, so I can't really test that. Or, it's just a web service layer. It just passes data between the database and my users, so I don't really need to test that. And I found out that this was, in fact, a fallacy. It was something that isn't true. It's never too simple to need tests. As well, another common one that I found was that I'm building a web part in SharePoint that displays a calendar, so therefore I don't need tests. So I'll show you how this all kind of ties together. So the first thing that I found was important to defeat this problem in your thinking is to think about the point of your application. If you sit down and you decide I'm going to unit test, which really at this point we can all assume that we are going to and that we need to be doing, we have to defeat this thinking, and the way to do that is to think about the point of your application. If your application does nothing, then it doesn't need tests. If it does something, then it needs tests. That's just the long and the short of it. Anything that you're doing requires some measure of logic behind it. So you really should be testing that logic. So think about the point of your application. The problem that I was having was that my program does something really simple. That's what I was telling myself. But yeah, it does something simple to me, but because I'm thinking about the scale of my program and everything like that, and where I'm starting is very, very simple. But in actuality, my program is doing all sorts of complex stuff, even though I may only have the framework in place. So I found that sitting down and thinking about what am I doing was the big thing. The next big thing was to use self-control and write simple code. So to give a little background behind that, I found that one thing that I was really missing, and a big critical error, was the fact that I had written code before I had written the tests for that code. And by when I say code, I'm usually meaning production code. So I'd written production code before I'd written test code, and that ended up being a problem to begin with. When we're talking about testing, really you need to follow test-driven development, or TDD. And the reason for that is not just because it's the way you're supposed to do things, but because TDD actually will help you write better tests and write tests to cover all of your code. I'll give you an example. I had sat down, I had written a couple methods, and I went to go test it, and I said, okay, well, this method or this class does a single thing. So I wrote a test for that method, and I moved on. Okay, it passes. I'm good. However, on going back, I ended up kind of realizing that this method does more than just edit an item for me. It actually edits that item and then sends a property change notification through the tree, and then sends one through a messaging class that I had installed in my program that will inform other parts of my program that, hey, I've been changed. Now I look at that and I think, okay, well that's a standard edit, right? However, I'm incorrect in that. I'm actually sending out all sorts of messages and doing validation, in fact, in that method. So I found that using self-control is key here. I want to go and I want to write this entire method all at once. I have to write very, very simple code. And so when we're talking TDD and writing simple code, I simply mean, I literally mean, I write saying that it should, it should call an edit method with this object, being supplied, and I literally write the method to do only that. I literally write the method to include a simple method call, a single method call, and then test for that. And anything else beyond that, sending that property change notification, for example, means another test. I need to tap into the property change notifications and make sure that that's being sent correctly. So again, it's remembering that every single line needs to be under test. You can use code coverage tools, but the best way is to start small. Only the bare minimum amount of code required to pass a test. If you need more code, you write another test, or you redefine your old test if it's not complete enough. And that can be frustrating. It can be frustrating to constantly fight against yourself and fight against your instincts to just write a bunch of production code. So I found that it's important to view your problems that you're having with these kinds of things as chances to better define your application and requirements. Because as we better define them for ourselves, we can help the client better define them. And when we better define our requirements and get more specific, we definitely get down to the nitty-gritty, because we all know the devil is in the details. We get down to the nitty-gritty of the application, and that's really where where your customer service comes in, is to take that to take the lead on that and make sure that you're delivering nothing but the best, even down to the details. And that's what makes a quality program. It's not the fact that we can edit an item, it's the fact that we can edit an item exactly as the customer imagined that we would edit that item. So making sure that we define the application and the requirements for our application is absolutely essential to giving the client exactly what they want. Now, we're going to go over this a little bit later, but BDD, business-driven development, can help facilitate and beat this kind of problem that we have in our thinking. Okay, next, I'm testing Entity Framework and I'm stuck. So I ran into this problem. I'm testing and I'm testing and I'm testing and I'm going testing crazy. I'm writing tests for all my class, and I can see my code become more covered, and my test numbers are increasing, and everything's passing, everything's green, it's great. And so I've hit Entity Framework, and I'm like, okay, I'm going to use Entity Framework, and now I want to test it. So I sat down and I spent a couple hours looking online. I looked at what was out there to test Entity Framework, and I said, oh, I want to make sure every single call into Entity Framework is okay. I don't want to actually test Entity Framework itself. I mean, somebody else has written that. We can assume that they've tested it, especially being a Microsoft product. But I want to test all the calls into it. And I came across a Stack Overflow where a guy had given a very simple, but in my opinion, the correct answer. And that answer was, you've gone too far. Essentially, the idea was that I'm testing too fine of a detail. Now, I understand that we want to test the details, but in this case, not every call into Entity Framework needs to actually be tested. I found it was important to determine a test's value before deciding to test something. So, for example, I can ask, well, what's the value in testing the business logic when I'm editing an item? Well, there's a lot of value in that. That's actually what our application is the business logic. It would be nothing without the business logic, and it would be useless to anybody without some business logic. So there's a lot of value in that. But what's the value in actually making sure that every single call into Entity Framework itself is correct? I'm not sure. I think that there's ways that you can structure your program to make it testable without having to actually, somehow intercept all the calls into Entity Framework. So you need to make a decision on the trade-offs involved. It's not very important that every single line of your code be covered in your with a code coverage tool. You're supposed to shoot for 100%, and I 100% agree with that. But you can spend 20 hours and really give yourself quite a bit of a headache to test every single call into Entity Framework. But what's the value in that? Personally, what I like to do is I like to mock up. I've been using the repository pattern actually in my current project that I've been doing a lot of this with. I use the repository pattern to make every single call into Entity Framework atomic, and then simply use all my repository classes as the only way to access data. I actually made a T4 template that turned all my Entity Framework objects into internal objects, and then anybody who wanted to access the database would use the public repository classes to access Entity Framework. If you want details on that, I can help you go over that. It was a pretty neat solution in my opinion. Kind of helped encapsulate everything really well and avoid duplication of objects, which I had to end up was an issue with mine. If you're interested, let me know. So the next one, my tests are a black hole. I found that people say a lot of times, oh, testing takes so much time, and even myself, I kind of ignored what everybody was saying. I said I'm going to test anyway. Well, actually, I kind of had to, but I said, well, I'm just going to test, and I found even myself, tests were a black hole. It kind of came to become a problem. I ended up finding that I wasn't maintaining my tests properly. Tests will suck the time away from you if you don't maintain them. But you know what? The same thing happens with production code. They will do the same thing. And I ended up finding that when I looked at my test code, I looked at it as like a second or a third or a fourth class citizen. It was kind of something there to help support my program, but it wasn't really essential to the function of my program. And as I was kind of going through all the different ideas and concepts behind testing, I realized that the error ended up being that my test code was not the best code in my program. In fact, now I really truly view my test code as something that is more important to me than, more important to the client than the production code. And the reason is because our tests are our requirements. And that's what the program really is requirements and business logic. And that's what those tests test. So if my tests are not there, I can write whatever production code I want. It might not be correct. My tests actually test the function of my program. So if refactoring extends to your testing code, if something's going wrong and we're spending time in production, even a little bit of time, and we're wasting that time, we'll refactor our production code in a heartbeat. But I found that a lot of people really resist refactoring their test code, and the reason is because a lot of people don't view it as important as production code. So it's very important to, I've found in my experience to refactor your test code. Create a service factory for any test objects that you might need. If you have a mock that you're using or something like that, make a test factory. It's if it requires a series of steps that you find yourself doing over and over again, make your tests maintainable and easy to understand, and you'll find that basically you'll spend your time writing your tests, and then you'll write some production code, and it's actually easier in some ways than writing your tests. So, again, I want to iterate, poorly structured code is going to be a black hole of your time, of your resources, of your energy. And that's regardless of where that code is. So test code, production code, whatever, poorly structured code means it's going to be a black hole. So testing with clients and QA. So one thing that I found was that you can write 1,000,001 tests if you want, that you can have 100% code coverage. The client does not understand that. They don't really understand what testing means, and even if they do, they don't want to see your test code. So I found myself wondering, well, when you're dealing with clients, and really anybody in between, for example, QA, they don't really want to go through your tests and figure out what the code is to understand whether or not your application is testing the correct things. They want to be able to see right away. That makes their job easier. You've written the test, it makes sense to you as a developer. And if you're using a mocking framework, sometimes it's not even just the code itself. Sometimes it's the frameworks that you're using that can get in the way of everything. So I found myself asking, well, how do I basically take all my tests, what I'm testing, and turn it into client speak so that I can ask the client if I'm testing correct things? So, test code can be hard to read, and clients, they really aren't even interested. Even if they could read code, they do not want to go through my test code to see if everything's correct. That's my job as a developer. So here we come to the topic of BDD, business driven development, or sorry, behavior driven development. BDD enhances TDD. TDD lives within BDD. So if you implement BDD within your application, which may or may not be the path you want to go down, don't think of it as replacing TDD, it enhances it. So you can do both. And it will help both client and QA make sense of the testing. Now, we'll go back for a sec, and we'll actually just go over what is BDD. Now, when you're talking TDD, you're saying, okay, well, what we're going to do is we're actually going to write a test, and then we're going to write some production code to make that test pass. And we're going to do it in a specific manner that will make sure that our requirements are well defined and that everybody understands what page we're on. BDD is behavior-driven development. And what it does is it actually asks, well, what is the behavior supposed to be? And let's clearly define the behavior. And when we clearly define the behavior, then let's make some tests for it. So when we're testing, we're usually testing for behavior anyway, but we sometimes always don't define behavior very clearly. And so a lot of times what I've found is that my tests, they will start to be kind of wrong in a logic fashion because I haven't clearly clearly defined my behavior. So for example, a behavior may be that whenever somebody goes to edit something, they must first require authorization from a role provider. Now I can write a test to make sure that a person is authorized in a role, but maybe my behavior isn't well defined and I don't know which roles I need to test for. No matter how good my tests are, they're going to be wrong, and I'm going to encounter an error down the road when the client comes back and says, well, this is incorrect. But I find that BDD typically helps with the cases where maybe you're dealing with an inventory system, and you say, well, if you have this much in stock and you go to refund this many items, you should now have this many in stock. And that turns into tests, and tests turn into production code. So if we follow BDD, it goes, spec, test, production code. And so we can kind of see this chain. And as we stick to BDD and TDD religiously, we'll actually find that our behaviors essentially turn directly into code. And by following these kind of methods to the letter, we'll find that we never write code without a test, and we never write a test without a behavior, which means that our behaviors and our code end up becoming very, very linked together. Okay, so this helps both QA and clients make sense of the testing. So how is that? Well, in BDD, we're actually going to write our behaviors in plain English. There's no way yet to write behaviors themselves in any sort of programming language that everybody can understand. It's kind of, I guess, a dream. So what we're going to do is we're actually going to take English, and we're going to try our best to translate that into tests, which will translate into code. And so this helps our clients make sense of the testing, because if possible, they'll be able to understand the tests. Now, I say if possible because tests can be very logic-oriented at times, and so we find ourselves a lot of times. Sometimes we can put too much on our clients in terms of critical thinking and logic paths. So if you have a very logical team, for example, a team of BAs, that might be really great for BDD. As where if you have a team of for example, small business owners that aren't really used to kind of dealing with a lot of these kinds of things, and we'll see here in a bit some syntaxes, and thinking about programs this way, you might have some errors. Not errors, I guess, but more just problems when you run into that. But as well, QA will be able to take and they want to specifically test behavior, and they're going to understand the logic behind it, and they'll be able to trace, okay, there's this error in my program, and I know I want this behavior, So, where's the problem? Is it in between? Is the problem the behavior, a problem in the code, a problem in the test? It can really help narrow it down really quickly for QA. As well, BDD provides an easy way to define requirements, because now it's in plain English, and it's very obvious what things mean. For most people, it's very obvious what a scenario will encapsulate, and what a feature and requirements mean. However, it does not solve the problem 100%. The way that I look at it is there's this kind of gap. There's this gap between the requirements, and there's a gap between the code. And with TDD, you take it as a gap between the requirements and a gap between the tests. But still there's that gap. Now, I find that BDD helps to bring this even closer. There's requirements, which you write a set of behaviors for. So it's now no longer a gap between the requirements and the tests, but between the behavior specifications and your tests. Now, while this serves to definitely bring that gap very, very close and try to close it completely, there's still going to be translation. And that's where we as developers, really truly that's what our job is to convert requirements into code ultimately. And through these different frameworks and kind of methodologies, we try to bring that gap even closer and make it as small as possible. But you're still going to have some errors in translation. So this isn't going to clean your code up completely. You're just going to have to deal with a different set of problems, which in some cases may be easier than dealing with the original set. So BDD, it's all well and great. We want to use it, but how? Well, the answer I've found, at least one answer, is Cucumber and Specflow, which are two things that I'm going to show you here. So to start off, Cucumber, what is it? Well, Cucumber is actually a syntax. Now, a while ago, a lot of people sat down and they said, well, we have this ability to create all these great things with computers, but unfortunately, we're having a problem translating requirements and giving them to other people. For example, if Joe writes a specification document, and he writes it up and he says, oh yeah, this is how the system should work, and it should go like this, and everything should flow this way. He writes that up, and he hands it off to Bob. And Bob takes a look at that and goes, yeah, this totally makes sense. This is going to be a great system. But Joe also hands it off to Steve. And Steve and Bob both agree, yeah, this is going to be a great system. So let's sit down and let's write some code. Now, Steve and Bob are going through the code, and all of a sudden they reach a snag. Steve has written one thing, and Bob thinks it should go another way. Now, they take a look at the document, and they sit there and they argue over, well, should be this way, or it should be this way. And they end up finding that it's not actually either's code that is incorrect. It's actually their interpretation of what Joe wrote. And so what we find is that, in any language, there's multiple ways that you can take something. And so what Cucumber tries to do is it tries to create a basic set of syntax that people can use to translate and transmit requirements. And so just as one might use a certain set of language, for example, in the programming world to help facilitate communication, in the requirements world, we're going to use Cucumber to do the same thing. So what does Cucumber look like? Well, this here is an example of a Cucumber statement. Given a precondition, when an action is performed, then I should have this result. It seems very simple, yet it's very powerful. When we understand what this entails and we know how to kind of parse this type of statement, we can give these statements out, and it can help kind of reduce the confusion that people get when they're translating, requirements to plain English. So this is all well and great, but what does it do for me? Well, we have to ask ourselves, how are we going to use this to make code? So what is Specflow? Specflow is actually going to take our Cucumber and it's going to help us turn it into code. So we're going to have on one hand a set of Cucumber statements, and on the other hand we're going to have some code. And we're going to see how Specflow will help us create one from the other. So we can see the Specflow uses Cucumbers to describe features and scenarios. Now a feature is anything. In fact, it's everything in your application. Everything is a feature. I've heard that passed around before, and it's kind of a almost a joke, but in this sense, it really truly is true. Everything is a feature. A UI is a feature. A method that does some work is a feature. Everything is a feature. So we have to, when you're dealing with this kind of stuff, you have to think of everything as being a feature. And a scenario is basically a set of outcomes given a certain set of inputs. I guess you could call outputs and inputs. Sorry, for a specific feature. So right now I'm going to switch over to Visual Studio and I will give us a demo in Specflow. So we're in Visual Studio right now. We're going to go ahead and we're going to start using Specflow to create some unit tests for us. If you've seen some of my earlier presentations, you'll notice our project structure here. However, if you're not familiar with it, the basic idea is that we might have a report that we need to create as an IT team, and that report will require us to pull from some data from somewhere, transform that data, and then publish it somewhere. So in this case, in this specific example, we're going to be using and kind of pretending that we're pulling from a web service, that we are transforming that web service data into XML, and then we're uploading that XML report to a web server. So what we're going to do is we're going to go ahead and test that. I have a test written so far, and we're just going to run our unit test using the ReSharper test runner here. Okay, so we see that the tests that we have created for this project pass. We are good to go. Okay, so Specflow. How do you get it? Well, there's two ways to get it. One is through an installer on the website. Another one is through a tool that's coming up in popularity really recently, and I can see why. It's called NuGet, and it's basically a package manager. You can add packages and basically install software pretty much with a click into your projects, add references and everything really quickly. I find NuGet is best used when you're operating within like a version control within multiple developers, because then you don't have to install a big list of tools and everything like that on the machines, because they put the binaries in a specific folder. So you just include that folder in your source control, and when everybody's pulling it down, they have the references right there. However, in this case, what has also happened though is that they have a series of project templates that are put into Visual Studio, item templates and whatnot. So personally, for me, what I did is I installed it from the installer, and that puts them into the DLLs into a folder somewhere in my program files. But then I also installed it into the project using NuGet. So my references to Specflow, if you can see here, are actually within my project folder. But I also get to take advantage of the item templates. So let's go ahead and start. So we're going to go ahead, we're going to add a new item, and we're going to add a feature file. We have to look at everything as, every piece of our program is a feature, so we're going to go ahead and we're going to call this execution. And we're going to say that that's a feature. Now, Specflow, when you're adding it, uses kind of use case of a calculator. So we're going to go ahead, we're going to replace those. But first, actually, I'm going to show you the app config. Now, I kind of set this up before, so we didn't have to mess around with it. But if you go into your app config, this is the configuration for Specflow. That's really it. And the only reason that I need this is because I'm using MS Test. If I wasn't using MS Test, if I was using the default, which is NUnit, I wouldn't have to configure anything. If I was using other providers and test unit frameworks, I might have to do some more work in here, but I mean, this is about as easy as it kind of needs to be if you're using NUnit or MS Test. So that's how you set it up, and that's pretty much it. Sorry. Okay, so we'll go back into our feature here, and we'll call the feature execution. Now, when we're talking about a feature in a scenario, a feature is going to end up being some functionality that is added to the program, and a scenario is a series of steps where we, perform a series of steps, and then we should get, we expect a certain result. We're going to automate that testing. So we're just going to type in a quick description here. Okay, so our scenario is that we're going to, have everything execute fine. So we're going to call it executes just fine. And now we have some preconditions here. So we're going to say, well, if I have provided a valid local path, so a path to kind of save the data that we get from the web service to with, and I have provided a valid remote path, so where we're going to put this data. When I execute the report, I'm just going to go ahead and, the report should run without error. There we go. So we have, our basic stuff here. If we go back to iReport, we're going to see that we have a local path, remote path, and execute. So we have everything that we need to do for our iReport. Okay, so we're going to go back here. So as long as we provide a valid a local path, a remote path, and we execute the report, we should get no errors. In this case, the report object is set up. My implementation is going to basically say if the local or the remote path is blank or null, throw an exception. And that's going to be how we report our errors, is through exceptions. So this is all well and great. We have our feature, but we have no unit tests. Well, with this one, we're actually just going to run the unit tests here. And everything looks good. However, here we see an inconclusive. And so what it's basically saying to us here is that it couldn't find a matching step definition found for the, each of these is considered a step. So it couldn't find the code that we had wanted to specify for that. So it's actually going to stub it out for us here. So this allows us to just copy paste all of our kind of stubbed out methods, and then we can fill them in ourselves. Excuse me. So what we're going to do is we're going to add a new item, and this is going to be a step definition. We're going to call this one execution steps, and we're going to let's pull this one out here. Close that. There we go. So we're going to kill this. We're just going to copy paste. There we go. So we can shut that down, and this now is kind of a skeleton for our steps and how we want to kind of define those. So next what we're going to do is we're going to take our feature, our financial report test, and in this case we're actually just going to go ahead, we're just going to duplicate this. This test over here actually just does the same thing. It just makes sure that, when everything's valid, that when we run our report, that everything kind of runs without error. So I'm actually going to show you how to take this kind of standard test and turn it into a test using Specflow. So in this case, we want to make sure that our tests are maintainable. So what we're going to do is we're going to create some methods to handle object creation. Let's make it a little bit easier to change in the future. As well, we're going to add some member fields here for the dependencies, so the mocks of those dependencies, for the object itself, for some test data. So we're going to go ahead and just add those in. As well, we're going to have an exception object to store any errors that are kind of kicked out of the code when we're executing it, so that we can capture it and see what the result is, if any. So just going to add our dependencies here. Transformer. report. Oops. And we're going to have a list of strings for our test data. Copy that over. And lastly, we're going to have an exception object. This is going to hold the exception that we get from executing our methods. Okay, there we go. So we have some, what do you call them? Member fields. So we're just going to add some initialization here. Boom, there you go. As we can see, we're actually kind of just copy pasting between them. Not a whole lot changes. There we go. We're just going to move that. There we go. So we're setting up our dependencies here. We're using mock-u in case you didn't recognize the mock objects. That's covered, in another talk that I gave. But basically, we're using it to mock out our objects. Okay, so we have initialized all of our objects. Now we're going to go and we're going to give some meaning to what it means to provide a local path, provide a valid local path, a valid remote path, what it means to execute a report, and what it means that when the report should run without an error. Now the great thing before we start here is that if you have two developers here, and you say in this set of objects and tests, you say this is what it means to execute the report, the next developer that comes in is going to see how that's done and understand how what it means to execute that report. And sometimes it can be fairly obvious how to run a report, but let's say it's a definition that you're more worried about. Maybe it's a definition of what active means. Maybe you have a series of objects, and you've said, well, object is active under this criteria. It can really help to kind of pinpoint some errors and mostly just increase communication between developers. Execute the report. This is the block. If somebody has a problem with that block of code that executes the report, we can talk about it as developers. But now we're talking about how the report's executed. We're not talking about whether it should be executed or not, or why it's being executed. That's already been established and everything, so it can help to increase communication. Okay, so what we're going to do here is this is a precondition, so we have to make sure that everything's kind of set up before. So we're going to say if the report is null, we're just going to initialize the objects. And then provide a valid local path. And in this case, a valid local path is any local path that isn't null or blank. So we're going to take, there we go, valid local path. We're going to copy paste, do the same thing with our remote path. There we go. What does it mean to execute the report? Well, because we have to handle exceptions, that's what our errors consist of. We're going to go ahead, we're going to capture the exception. Whoops. There we go. And we're going to say that report.execute. That's what it means. So we're going to wrap the whole thing in a try-catch. We're going to store the exception up here, if there's any. And then we're going to say, well, what should it mean when the report runs without an error? Well, we're going to say that, we're going to assert that is null is that exception field. So basically that we didn't receive any exceptions. But on top of that, we're actually going to verify that our methods are being called correctly. This mock-u verifies what method calls were made to your dependencies. And so we're just going to make sure that everything's being called and with the right parameters and everything like that. So everything's kind of set up here. We have a great little test here, and let's go ahead and run it. Now the feature is actually going to have a feature.cs, and that contains all of our unit test code. So these Specflows, feature definitions, all these step definitions, all they're doing is they're actually just creating unit tests. So if you have any need to run certain tests at certain times, or you have different builds in some sort of continuous integration environment, you can use all the same set of tools and processes that you would use for unit testing with this. Okay, so we've gone ahead, we've run with the Resharper test runner, our unit test for the entire project, and we see our executes just fine. Success. So right now we can see that these two tests test the same thing, they perform the same thing. However, this one over here is backed by a nice little plain English description of what it does. Again, I mean, this is readable, people can read it, developers can read it, QA can read it, and if the clients have a great BA team, they can read it too. Excuse me. Okay, so that's great. We're going to shut down this other test here. But let's test another scenario, right? That was our primary scenario. But let's test, and I'm going to show you the reuse capabilities of Specflow as well. So let's say let's say it's going to report error on an invalid local path. So this scenario, what we're going to do is we're going to provide an invalid local path with a valid local path. We're going to execute the report, and we're expecting that the report should give an error. So there we go. We've kind of copy-pasted and modified our scenario. We're going to go ahead. We're going to run this unit test again. We're going to see again an inconclusive. We have two different steps here. Instead of the four last time, this is just going to cover the new way of the new steps that we've kind of provided. So there we go. We're going to copy and paste these in. And we're going to specify them. So we're going to copy this one, paste it down here, and like I had said, blank is considered invalid in this case. So we've provided an invalid local path, and then we're going to define what it means when the report should give an error. So report gives an error if that exception member field is not null. There we go. We're going to run this test again. Boom, runs fine. So we even get some little times out from right here. So that's basically how easy it is to take and reuse. I mean, we reused valid remote path. We've reused the execution portion. So if you have an object that's used over and over and over again in your tests, you don't have to specify how it's executed, for example. You can just set it up once, as well as it provides for everybody else that's working on the team kind of an example of how that report should be run. So that right there is pretty much Specflow and how it works. You can see that it's kind of reusable, plain English, turns it into a test, and by following TDD and BDD regularly and very strictly, you'll see that you end up taking your plain English business requirements, which might be in a proposal or spec'd out by a lead or something like that, and it turns it right into code, and we can kind of follow through how those requirements turn into code, so that if we ever have a problem with our code, we can backtrace it to the requirements, or if we have a change in the requirements, we can trace it into our code really easily. There's no guesswork there. So that's Specflow. Okay, so now you've seen Specflow in work, you've seen how it can be fairly useful to us when we're dealing with clients and requirements and everything like that. So in conclusion, there's some common pitfalls that can be avoided by focusing on what the tests do for you. Don't worry about, don't think of your code and your application as a set of code which your tests support. Think of it the other way around. Your tests as requirements, and your production code simply enforces them. As well, we can see that following TDD to the letter helps you as a developer ask the right questions of your applications, and helps you flesh out those requirements, which sometimes can be a little vague. And BDD can help supplement this, and that can help communicate requirements to the clients. Again, the goal here being to make sure that the requirements are exactly how the client wants them, and that everybody is happy. and that we all do it in a really easy way. Lastly, we saw that Specflow and the Cucumber syntax can help keep your requirements and tests in line and in English. We saw how we can see how when we take our requirements, we can turn them into code, and that when one changes, we kind of have to change the other. So this would be a time where I would ask questions in an interview. However, if you have any questions after watching this video, feel free to send me an email or just come up and talk to me. Thank you very much. I hope that you enjoyed watching. Have a good day, and good luck on testing.